Hi everyone, we're from the Eagle and today we're going to show you how to use our system. You can start the query by pressing the command or control button with the K, and right here we are searching for a man in black. And from all the results photos here, you can also click right to submit the image or zoom in the image. And you can also see the other image of this day or this time of the day. You can also expand the group of the image, and you can also see the image that grouped by location or by day. And to submit the Q&A answer, you can press the command or control button with the Q to submit the answer. And our system also uses the eye tracker. So when we find the position that works best for the eye tracker to capture your eyes, try not to move your head or change your position. Thank you for watching.
Hello everyone, I'm very happy to present the VideoEase retrieval system, which is designed for efficient and intuitive search. User can input a query on the three box of query in free text to describe what they are looking for, and the retrieval system will find the video clips, filters such as RCR, color, and objects are allowed to specify more about the queries. In addition, we also support visual similarity search, which is searching image by images. In addition, we also have designed for temporal search to make it easy to navigate video sequences and track events over time. This video retrieval system is expected to provide a comprehensive way for users to explore and retrieve video data. Thank you.
This is Vitrivr's contribution to the Video Browser Showdown 2025. What is currently done in video retrieval is that a video is segmented into a series of shots, for each of which a feature is extracted, and based on these feature representations, retrieval can be performed. However, this segmentation mechanism and this feature transformation is commonly completely independent, possibly introducing some mismatch. Our main contribution this year is a mechanism that tries to align these things by sampling a video at a higher rate and extracting a feature for each of these samples, resulting in an overabundance of features. Consecutive features are then merged if they are too similar to each other, resulting in a more representative sampling.
The Vitrivr browser system allows you to search for videos using a query, like a query of red double-decker bus in London. The result will be returned on the left side, and you can browse the result by scrolling down. Simply clicking on any of the shots will guide you to the temporal shots of that particular video. The video itself will also be played on the bottom right hand side. GPT suggestion will also be generated if you click on the generate suggestion button. You can also search with the generated suggestions. You also can use the generated images by Stable Diffusion to search. We also support filtering with different types of settings: black border, black white, dark, and also excluding them as well. Multiple models also can be used to search. We can choose the model type there. We also support color search, OCR search, ASR search, meta search, and not query search.
Welcome to Vifi, our video finding system showcased at Video Browser Showdown 2025. First, let's start with the text search, which is powered by SIGLIP features and a customized keyframe extraction process. After selecting a result, you can preview the video, browse through the keyframes, and submit your answer. The system also supports finding similar frames with the selected keyframe in the video. We also can use the filter feature to narrow down results. Simply set your criteria with the quantity, click Search, and see the updated results. Our system also supports temporal search, which allows users to search for time-related sequences. With the first query for the current information and the second query for future information, Vifi displays results corresponding to the user's temporal queries. Finally, let's try image search. Upload an image, like this one of Nemo, and Vifi quickly retrieves matching video frames. Thank you for listening.
Welcome to the ViewsInsight 2.0 retrieval system, proudly featured in VBS 2025. Building on the foundation of the previous version of ViewsInsight at VBS 2024, this upgraded version offers a more user-friendly interface and even greater retrieval capabilities. With our redesigned user interface, navigating between tasks is now as simple as a single click. Users can effortlessly switch between view modes to suit their needs. Choose a single image view, a cluster by video mode that shows the top 3 images from each video, or a horizontal layout displaying all images for comprehensive browsing. Provide relevance feedback to refine the system's understanding and enhance the accuracy of search results. Dive deeper with the detailed view of images and discover related visuals effortlessly through the Nearby Images feature. Use the VQA feature to ask insightful questions about selected images and receive precise answers. When working on tasks like video KIS, users can leverage the power of Google Image Search to find relevant visuals and seamlessly use the visual search feature by copying these images into the system. This allows for intuitive and efficient exploration of visually similar content.
Is an interactive video retrieval system developed by CertITI. The system provides 2 modes, Novice and Advanced mode. In Novice mode, users can search either using free text queries, or selecting the number of people or faces in the images. 2 queries can be combined for a temporal search. In Advanced mode, users can also search by the color of image tiles, or by choosing from predefined concepts. 2 queries can be combined for a fusion or temporal query. The results drop-down can be used to retrieve all matching frames of a video, or only the first one. In the LabGYN dataset, users can click on the Draw Tools option to retrieve medical images that contain tools in specific positions. The engine enables detection of visually or contextually similar images. Video shots can be explored by either clicking on a specific one, or watching the corresponding video. Finally, users can submit a shot or a video time.
This is a quick demonstration of Exquisitor, the multimedia retrieval system that allows you to perform regular search and user relevance feedback. We start off by going into a collection and entering our search query. Now we see the results of our search query of Japanese gardens, and we can see the video and, well, Japanese tea gardens straight away. We can also see other segments in the video down here, and these will be looping, so we can stop the loop and actually jump around in the video if we want to as well. We can also perform a second search. Let's go for Japanese temples this time, and then view those videos. We can also go back to the previous search and see that again. We can also open up a new search in a different collection, and let's go for the marine collection and search for corals, which may not be the most descriptive search, but here is where we can use user relevance feedback to indicate which types of shots we want to see more of and which we want to see less of. And then once we've given that feedback, we can hit the show feedback results, and we'll be in a different area that is closer to what we want to see. This was a quick demonstration of Exquisitor. I hope you enjoyed. Thank you for listening.
Vitrivr VR is a virtual reality multimedia retrieval system. In its new version, it is built from the ground up for the Apple Vision Pro, allowing intuitive input through physical keyboards. Results are displayed in individual windows that can be placed anywhere within virtual space. By changing the size of result windows, the number of items that are displayed can be changed dynamically and flexibly, allowing the information density to be directly controlled. Placing and resizing windows within the virtual space allows as many different media items to be viewed at once at any time.
DiveXplore 2025 combines a flexible and powerful user interface with state-of-the-art content recognition, such as visual recognition with open clip using vision transformers, speech recognition with Whisper using an encoder-decoder transformer with GPT-2, and text recognition with ECOCR that is based on Craft. The results of the recognition can be searched with a free text query that also supports temporal filtering. Results can be quickly inspected with a nice scrubbing feature, or in more detail with a large keyframe, a summary of the corresponding video, or a video player. If users need more information on the video structure, they can also switch to the shot view for a video. This also shows all the metadata and the detected text and speech. Finally, we also support similarity search that returns similar results for a selected keyframe.
This is NII-UIT team, so this is our system. On the left hand side is the place where you can enter your query. For example, a man riding a bike, hit enter, and in just a second all results will be shown here. You can right click to show the full resolution, hold control and click on a result to see on a nearby keyframe. Double click this to search for a similar keyframe. Click on this button to play the video at that moment, like this, and click this button to submit. For temporal search, you can click on add here to add a state in the temporal search. For example, I will search for a woman in a red dress, a party, outdoors, and drinking. Hit enter, and in just a couple of seconds you will see that okay, woman in red dress, stage 2 outdoor party, and stage 3 someone is drinking. So that is a multi-stage search, and for each stage you can use a lot of query like text query. You can use an image to search for the similar keyframe, or you can also input object, for example like person, and the person will be greater than 0, it basically means that okay, there's person in the keyframe, or you can also equal to 0 for no person, for example. Yeah, so that's all from our system.
Hello, this is Team Proc, and we present the third version of our Interactive Video Retrieval framework. In this version, we streamlined the user interface and removed redundant UI elements in different task views from our menu. We further believe in the powerful capabilities of temporal querying, where we enforced different frames with independent user descriptions need to be contained sequentially in a single video. We further extended this extra context to the image browsing with additional location information to user queries that can be quickly attached to text queries using predefined text abbreviations. This strategy enables the localization of different objects or scene elements when landmarks are sparse, but they can be identified by their unique placement in the scene. Decoupling the localization information also helps to reduce the length of queries, leaving more room for description, and reduces typing time for practiced users. When no placement information is provided, the framework will perform a normal query over the whole image context. Our localization strategy of using a 5-element overlapping grid has shown to yield promising results in a pilot study we conducted.
MediaMix is a multimedia retrieval system that reimagines how users interact with and explore digital content. Developed for the Apple Vision Pro, MediaMix leverages mixed reality to deliver an intuitive and immersive experience for multimedia search. MediaMix enables users to issue text queries by describing the desired scene. It is powered by a server using Vitrivr's data format, ensuring robust and efficient retrieval. A key innovation of MediaMix lies in its result presentation. Search results are displayed on an interactive sphere, offering users an engaging way to explore their findings. With simple gestures, users can rotate the sphere to navigate through results. Using eye tracking technology, the currently viewed objects are highlighted. Selecting result is effortless, allowing users to open the complete video with a pinch. MediaMix transforms multimedia search into an intuitive mixed reality experience.
Welcome to SnapSeek 2.0 at VBS 2025. Let's start with a simple query, a pinfish in NVK dataset. Our interface features two primary search modes, Neighbor and Similarity. The Neighbor tab displays a linear sequence of keyframes related to your query, while the Similarity type organizes results in a grid ranked by similarity score. Simply click the eye icon to open a pop-up showcasing the neighboring keyframes of any retrieved image. Double-click an image to instantly reveal a gallery of similar images, offering a deeper exploration of visual connections. Tailor your results with our feedback feature. Click the like button to prioritize similar images, or dislike to filter them out. Using a pair of queries separated by a vertical bar to search for temporarily related frames in the dataset. Sketch-based retrieval with two flexible modes, positioning and brush, you can visually craft your query. Place objects using bounding boxes in positioning mode or draw directly on canvas in brush mode. We also support a dictionary of surgical tools and creatures in NVK and LHE datasets to acquaint users with those datasets. The demo presentation of our team IM Search at VBS 2025. Here is the overview of our system. We propose 6 different modules with first, semantic search. Second, OCR search. Third, automatic speech recognition or ASR search. The fourth is the object location, where you can draw bounding box and assign a local label. The fifth one is the color search, where you can choose a color and search for the corresponding image. The sixth function is the combine whatever you want with this. There are some basic functions that user may interact with. First, you can select an image and zoom in to see the full image. From that, you can submit the image or typing the text to submit the QA function.